Okay, so let's get right into it. We are in the middle of a quiet revolution, one where robots are no longer just solo acts. They're actually becoming teammates, learning to collaborate in ways that, frankly, we've only ever seen in science fiction. And it's all being made possible by the power of generative AI.
But that immediately brings up a massive question, right? A challenge that has been a real headache for engineers for years. How on earth do you get these incredibly specialized machines, one flying in the air, one on the ground, one deep underwater, to actually coordinate and work on the same mission? They don't speak the same language, they don't even see the world in the same way.
And this really shows you the shift we're talking about. The old way was all about solo robots stuck in their own lanes, just following a rigid, pre-written script. But the new way? Well, that's all about AI-powered teams. These systems can collaborate, they can adapt, and they can even cook up new strategies together right in the middle of a mission. It's a total game changer.
So, that brings us to our first section, the Grand Coordination Challenge. You know, for the longest time, getting these different kinds of autonomous systems to play nice together was, well, a nightmare. A swarm of drones and a team of ground robots were like experts from totally different fields who couldn't communicate. Each was running on its own special code that just didn't scale or adapt to new situations.
Think of it like this. You've put together an absolute dream team of the world's best specialists, but none of them share a common language or a unified plan. That was pretty much the state of multi-domain autonomy. All this incredible potential just locked away because they couldn't talk to each other.
So what changed? What broke the logjam? Generative AI. It's really emerged as the breakthrough that acts as both a universal translator and a master strategist. It's finally allowing these diverse machines to understand each other and, more importantly, to understand the big picture mission goal.
The first key ingredient here is the large language model, or LLM. These are those massive AI models that have been trained on just insane amounts of data. And the real superpower isn't just generating text. It's their ability to do what's called contextual reasoning, to understand a complex goal and then break it down into a series of logical steps.
So the crucial takeaway here is that an LLM can act as the AI team captain. A human operator can just give it a high-level command in plain English, and the LLM can generate a specific, coordinated playbook, assigning a unique role to every single robot on the team. It's amazing.
Now, the second piece of this AI puzzle is the diffusion model. And the way these things work is just wild. They start with pure randomness. I mean, think of a cloud of TV static. And then, step by step, they refine that chaos, chipping away at it until what's left is a perfect, coherent output. In our case, that output is a complex, collision-free path for dozens of robots to follow.
So how exactly do these AI tools forge teamwork? Let's break down how they turn a collection of individual machines into a true cohesive team. It really boils down to a few core capabilities.
First, the AI handles dynamic task allocation. That's basically deciding who does what and when on the fly. Second, it manages conflict resolution, which is a fancy way of saying it makes sure robots don't literally bump into each other or mess up each other's work. And third, it enables adaptive communication, so they can efficiently share what they're doing and what they're planning to do next. And this isn't just theory. In one study, a multi-robot team guided by a planner based on GPT-4 explored an unknown environment almost 23% faster than teams using traditional methods. The AI was simply smarter at assigning waypoints, and it could even understand semantic hints like the target might be at the end of a corridor. And for that conflict resolution piece, the sculptor analogy for diffusion models is just perfect. Imagine a busy warehouse. A diffusion planner can take the chaos of all possible robot movements and just carve out a fluid, deconflicted motion plan. The result is dozens of robots moving in perfect, efficient harmony. Okay, so this technology is already moving out of the lab and into the real world. Let's take a look at some of the operational frameworks that are making these smart swarms a reality today.
Two of the big players in the defense space are Anduril and Elbit. Anduril's Lattice platform is like a central AI for command and control. It fuses all the sensor data together and lets a single person manage swarms across air, land, and sea. Elbit's Legion X, on the other hand, is really focused on creating a super robust and secure network, one that allows different kinds of drones and robots to work together even when they can't get a GPS signal. So you might be asking, how do you even train these swarms for every possible situation?
Well, you use digital twins. Generative AI is used to create these incredibly realistic virtual worlds to test and train the autonomous systems. You can generate millions of different scenarios, from different weather conditions to unexpected enemy tactics, and really stress test the AI before it's ever deployed.
But, of course, as with any really powerful technology, this rapid progress comes with some serious challenges and potential dangers that we absolutely have to address. Which brings us to the most critical question of all. Can we actually trust these systems? When an AI is generating plans for physical machines that are moving around in the real world, ensuring safety and predictability becomes everything.
And the research points to 4 major hurdles. First, their behavior can be unpredictable. Second, they can have security vulnerabilities. They can be tricked by malicious data. Third, their decision-making can be too slow for real-time reactions. And finally, and this is the big one, they raise profound ethical dilemmas, especially when lethal force is involved.
So with these risks in mind, what does the path forward look like? How do we harness all this incredible potential responsibly?
Well, the consensus seems to be pointing toward 3 key areas. First, building hybrid systems that combine the creativity of generative AI with the reliability of classical, verifiable controls. You get the best of both worlds. Second, developing collaborative tools where humans and AI plan missions together. And third, investing heavily in secure communication protocols to prevent hacking and interference.
Which leaves us with one final, fascinating question to think about. As these autonomous systems evolve from being simple tools into true, intelligent teammates, our entire concept of command and control is going to have to evolve right along with them. The future of autonomy isn't just about smarter machines, it's about redefining the partnership between humans and AI.